probably heard the name Python, right? It's kind of the quiet engine running behind giants like Google, NASA, and even Industrial Light and Magic. But what is it really? And why has it become one of the most popular programming languages on the planet? Okay, let's dive in and pull back the curtain on the superpower behind so much of our modern tech.
So to really get Python, you first have to understand the problem it was built to solve. For the longest time, writing software has been, well, it's been hard, like really difficult. The tools were often clunky and super unforgiving, which created this huge gap between having a great idea and actually, being able to build it.
But Python's creator had a totally different vision. The goal was to make a language so clear, so readable, that it could basically be described as executable pseudocode. Now just think about that for a second. The idea is that the code itself should read almost like a simple, plain English description of what you're telling the computer to do. This whole philosophy of simplicity, it's at the absolute heart of Python. So, how does Python actually achieve this? Well, it's way more than just having clean-looking code. It's a fundamental shift in focus. It's built on a philosophy that values your time, the programmer's time, way more than the computer's time. See, every single programming language has to make a trade-off. On one hand, you've got languages like C++ that can run incredibly fast, but man, they can take a long time to write and get right. On the other hand, you have Python, and Python makes a very deliberate choice. Let's prioritize the speed of development. The thinking is that a developer's time is the most expensive resource in the equation, so your tools should make them as fast and productive as humanly possible.
All right, let's break down what this philosophy of simplicity actually looks like when you're writing code. It comes down to a few core ideas that make Python so approachable, even if you've never coded before. Now, what's so cool about these principles is how they all work together. Take the simple syntax, for example. It's not just about looking nice. By getting rid of all the extra brackets and semicolons you see in other languages, Python's very structure kind of forces you to write readable code. And that is absolutely crucial, because readable code is maintainable code, which really just means you'll spend less time 6 months from now trying to figure out what on earth you were thinking.
Okay, another massive piece of Python's power is what it gives you right out of the box. Instead of making you build everything from the ground up, Python just hands you these powerful, high-level ways to store and organize your data. I like to call them your super tools. First up is the list, and it's exactly what it sounds like. A collection of items, stored one after another in order. You can add things to it, you can remove things, you can move them all around. It's super flexible, super powerful, and just incredibly useful for managing any group of things where the sequence actually matters. The second super tool is the dictionary. Oh, this one is just brilliant. Instead of storing items by their position, like first, second, third, a dictionary stores them by a unique key. It works just like a real-world dictionary. You look up a word, that's the key, to find its definition, that's the value. It is the perfect tool for connecting one piece of information to another.
So here's the bottom line. It's all about how you access your data. With a list, you're asking, what's the third item on my shopping list? But with a dictionary, you're asking, what's the phone number for John Smith? See the difference? One's about order, the other's about association. Having both of these built right in saves programmers from writing mountains and mountains of code just to handle their data. Now, Python doesn't just give you great tools. It gives you an amazing way to build your own tools. And this is where we get into the idea of reusable modular code, which is really the cornerstone of all smart software design. So instead of copying and pasting the same chunk of code all over your project, Python really encourages you to package it up into things called functions and classes. Think of them like custom Lego blocks. You build a block that does one specific thing really well, and then you can just reuse that block anywhere you need it, as many times as you want. And this right here shows off one of the coolest ideas in programming, inheritance. You can think of it like a family tree for code. At the very top, you might have a general employee with basic traits. Then you can create a more specialized chef. Now, because a chef is an employee, it automatically gets all the employee stuff. Then you can get even more specific. A pizza robot is a chef. It inherits everything from both the chef and the employee. And all you have to do is add its unique pizza-making abilities. It's all about building on what's already there, instead of starting from scratch every single time.
Okay, let's zoom out for a second. All these awesome features, the simple philosophy, the built-in tools, the reusable blocks, they don't just exist on their own. They've all come together to create one of the most powerful and supportive ecosystems in the entire world of technology. And we're not talking about a language for hobbyists here. This is for mission-critical stuff. Google uses it for system administration. Industrial Light and Magic uses it to create special effects in huge blockbuster movies. NASA's Jet Propulsion Labs uses it for space exploration. These organizations are betting on Python's productivity and reliability for things that absolutely have to work. And they are definitely not alone. The Python community is estimated to be over 1 million developers strong. Just think about what that means. It means if you run into a problem, chances are someone else has already solved it. It means there's this massive library of pre-built code for almost anything you can imagine, and a huge support network to help you out when you get stuck. But all of this, it brings us to that final, crucial question. The elephant in the room that always comes up when you talk about Python. What about its performance? So let's just be real. When you compare it to a low-level language like C++, is Python's raw code execution fast? Well, the short answer is no, it's not. There's no getting around that. So the big question really becomes, does that actually matter? And here is the answer. This single sentence really captures the entire value of Python. For the vast, vast majority of things people build, the time you save in writing the code, testing it, and fixing it later is so much more important than the few milliseconds you might lose in raw computer speed. So the true superpower of Python isn't about machine speed. It's about human speed. It's about empowering your creativity and drastically shortening the time it takes to turn an idea in your head into a real working program. That is its game-changing advantage.
Which kind of leaves us with this one last thought to chew on. We know that the tools we use have a huge impact on how we think and what we're able to create. So if Python has already helped build so much of our digital world by focusing on simplicity, you have to wonder, what will the next generation of creators, empowered by these same principles, build next?